Now, continuing with our elements, we just saw, we just looked at the periodic table. We just defined what periods are and what groups are. Now we'll go back to the elements. I said that the identity of an element is given by the atomic number. So the identity or name of an element so the identity of an element is given by the atomic number, and we know that the atomic number is the one that is down here. So this one, so this is atomic number, another atomic number here, the same thing, atomic number. This one is atomic mass, we call it mass number. This one is mass number, this one is also another mass number. As you can see, all these three have the symbol of carbon, C. But you see the masses are different. That's why you cannot use mass to identify an atom. You can see the atomic numbers are just the same. That's why all of these are carbon. All of these are carbon because they have the same atomic number. We don't care about the differences in mass. What we care about more is the atomic number. If you say atomic number 6, that is carbon. Now, in most cases, we have atoms of the same element, but that differ in their number of mass numbers. So they differ in mass numbers because of the neutrons. For example, this one, I'll call this one A, this one B, this one C. So A has 6 protons and 6 neutrons. Therefore, its mass is 12. B has 6 protons, and because it has 6 protons, it is carbon. Has 7 neutrons. That's why its mass is 13. C has 6 protons and 8 neutrons. That's why its mass is 14. So atoms that have the same atomic number but different masses are known as isotopes. So you can write this down. So we can say these are atoms that have the same atomic number but different mass number. Why do they have different mass number? Because they are different in the number of neutrons. So the isotopes will differ by the number of neutrons. So take note of that and the definition itself. Now, if we go back here, we'll see that this isotope There's carbon 12, carbon 13, carbon 14. This carbon 14 is radioactive. So what do we mean when we say radioactive? Radioactive is just atoms that release energy in form of subatomic particles. For example, carbon 14. Carbon 14 releases energy in form of subatomic particles or some rays, while the other carbons do not release that energy. So when you talk about what is a radioactive material, a radioactive material is the one that releases energy from the nucleus. So that's what happens. It releases energy from the nucleus. So a radioactive material releases energy from the nucleus. So radioactivity involves 3 particles. So you need to write these particles down. Radioactivity involves release of 3 energy particles or rays. So one of them is called alpha particles. So if a substance is releasing alpha particles, it is given as a symbol alpha. If a substance is releasing alpha particles, that substance is releasing radiation. The other particle that it releases is known as beta particles. So a beta particle is given a symbol B. And the third radiation that is released by an atom is called the gamma rays. So the symbol for gamma is that kind of Y. So these are the 3 particles that a substance releases when it undergoes radiation. You need to write these down. Now, when we talk about radiation, we also think about the levels. What are the levels of radiation? Depending on how much radiation is being produced, radiation can be dangerous or can be beneficial. So normally when you have low radiation, that is when an atom is emitting very little amount of radiation. The behavior of an atom is like, it's like actually it's like you don't have the radiation. Maybe you can have a very little energy of radiation, maybe for 2 months or maybe 2 years, or from an atom. And then you can say, this one is releasing radiation, but it is releasing the radiation too slowly, that it really doesn't matter. So these types of low level radiation are used in medical fields. So you can use this in medical field as tracers in body imaging. So what happens is you have an atom that undergoes radiation. So a person drinks that atom or drinks a substance containing that atom. As the atom is passing through the body, you can use a detector. If there is a tumor, when that radiation gets to that tumor, it will activate a certain type of detection that a doctor can use that detector to determine, oh, based on the sound of the detector, there is a tumor. Based on the color that I see there is a tumor. Or based on this color, there is no tumor. But that color is available only when you put in something that is undergoing radiation. If someone drinks something that is not undergoing radiation, when you go to that tumor, there will be no color change, because there is a response between the radiation that you are dealing with and the cancer tumor, and also epilepsy and Alzheimer. So the issue is, we can say that we use low level radiation to detect cancer, epilepsy, and Alzheimer's disease, among others. So ADC. Then we have high level of radiation. So we are talking about these two types of radiation: high level radiation or two levels. That is not two types, two levels of radiation. If we talk about types, we have three types of radiation, as we saw here. We have alpha radiation, beta radiation, and gamma radiation. But if we talk about the levels, we have two levels of radiation: low level and high level. So this one is harmful because it can change the DNA of cells. So it can change the DNA of cells and therefore produce mutations. So mutation, it really is the changing function of a cell. That's what the mutation is about. So there's this high radiation going to the cell. It hits the cell and it ionizes some materials within the cell and then change the function of the cell. Once the function of the cell changes, people develop a lot of things. One of them is cancer. But high level radiation can also be used to treat cancer. We use it in radiotherapy. So radiotherapy, they use radiation to kill tumors in the brain and other parts of the body. We can use it to sterilize equipment, medical equipment. Sterilizing means killing bacteria and other microorganisms. So I say killing microorganisms from medical equipment. That's what it means when you say it is used in sterilizing medical equipment. And also they use it to sterilize US mail. So these are three ways that we can use high level radiation. They use it to sterilize US mail and other packages so that the mail does not contain pathogens like anthrax, bacteria. So these pathogens are things that can cause diseases. Organisms that can cause diseases, even death. So write that down. So how can we use high-level radiation? Three ways: radiotherapy, sterilized medical equipment, sterilized US mail. So here they're just showing how you can use low levels of radiation and high levels of radiation. Now, let's go on and talk about an electron. What is an electron? Or when you talk about an atom, what is a neutral atom? So neutral atom has equal number of protons and electrons. So because of that, the protons are positively charged, the electrons are negatively charged. When you have equal numbers, the charges will cancel. So in the end, they have a total of 0 charge. So have a total of 0 charge. So what we are saying is a neutral atom does not have charge because it has equal number of electrons and protons which cancel each other. One of them is positive, the other one is negative, so they will cancel each other. And we said electrons are found in energy levels. And really, if I talk about, let me just show you. So I have an atom here. And this atom has a nucleus. So the nucleus has maybe 15 electrons. So from the nucleus, I have the first cell. The first cell is going to have a maximum of 2 electrons. Because if I have 15 protons here, 15 protons also means 15 electrons. So we need to take note of that. So the first shell will have 2 electrons. And I am remaining with 13 electrons. The second shell always has 8. Not always, but it has a maximum of 8 electrons. It may have less, but not more than 8. So here I have used 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From 15, I am remaining with 5 electrons. So these 5 electrons, I'll put them outside here. And I'm not going to have a maximum. That's how electrons are divided inside an atom. The first shell has 2 electrons. The second shell has 8 electrons. The third shell has 8 electrons. So I'll say first shell, maximum 2 electrons. Second shell, that is shell, not cell. So shell. Second shell, maximum 8 electrons. Third shell, maximum 8 electrons. So really, you have your nucleus here. You have 2 in the first shell. You have 8 in the second shell. You have 8 in the third shell. And you increase the numbers as you increase the shells of an atom. So we say each additional shell contains 8 electrons. Normally when filling electrons in an atom, you start with the shell closest to the nucleus. So as I showed you, I started filling here. I started filling this shell that is closest to the nucleus, and then I filled this shell, and then I went to fill the outer shell. That's how you deal with the atom. And if you take the nucleus as this one, and we have this, we have the first shell, we have the second shell, we have the third shell. This shell inside here has lowest potential energy. So potential energy is energy of position. So the cell inside, close to the nucleus, has the lowest potential energy, while this one has the highest potential energy. That's why we call these cells energy levels, because they are shells of energy. So this is what they are showing. If you are filling, hydrogen only has a single electron. So you put the single electron in the first energy level. So this is energy level 1. Energy level 1. So that is energy level closest to the nucleus. Energy level 1, energy level closest to the nucleus. While this one, we have energy level 1 inside, and then we have energy level 2. So we start filling this inside, and then we go on to fill the outside. So carbon has 6 protons inside here, therefore it should also have 6 electrons. 1, 2, 3, 4, 5, 6 electrons. Nitrogen has 7 protons, it must have 7 electrons. 1, 2, 3, 4, 5, 6, 7. And you can see we have 2 electrons inside here. That's how we fill it. For carbon, we have 2 electrons inside. And because we are supposed to have 6 electrons for carbon, if we use up the electrons inside, we remain with 4. So the 4 electrons, we distribute them in the outer shell. So this one is the outer shell. Nitrogen has 7 electrons. So we have 2 electrons inside here. We are remaining with 5. So the 5 electrons, we put them in this shell. Oxygen has 8 electrons. So we have 2 inside. The 6 remaining electrons should be in the outer shell. Phosphorus has 15 electrons as shown here. Because it has 15 protons, it means it has 15 electrons. So how do we share them? The first 2 electrons go inside, and the second 8 electrons go inside here, in the middle one. So in the end, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 electrons used. How many are remaining? 5. The second shell cannot have more than 8 electrons. Therefore, once we get to 8 in the second shell, we need to jump and go fill the outer second shell. So you can see 1, 2, 3, 4, 5. While sulfur has 16 electrons, which means the outer shell will be filled by 6 electrons also. So take note of how we fill. The first shell is 2 electrons, the second shell is 8 electrons, the third shell has also a maximum of 8 electrons. It can have 8 electrons or less, depending on the number of electrons that you have. So here we are revisiting the periodic table. They are just trying to talk about what I already said, that the vertical columns are known as groups. So these are groups. The horizontal rows are known as periods. So what does group number mean? As you can see here, this part is group 1, which means any atom in this one has 1 outer shell electron. So 1 outer shell electron. What does it mean? Hydrogen. Hydrogen has a nucleus and a single electron. Lithium. This is the outer shell electron. Lithium. Lithium has a nucleus, 2 electrons inside, and a single electron outside. What about sodium? This is hydrogen, this is lithium, this is sodium. Sodium has a nucleus, 2 electrons inside, 8 electrons in the middle, and 1 electron outside. So you can see that anything that is in group 1 has 1 electron outside. And because of that, we say that, oh, that atom is in group 1. This atom in group 2 here, they have 2 electrons outside. These ones have 3 electrons outside. These ones have 4 electrons outside, 5 electrons, 6 electrons, 7 electrons, and 8 electrons. So what does it mean? The vertical columns, or the group numbers tell you the number of outer shell electrons. So I'll just give myself more space here. I hope you have already written this part. If not, stop the video and write this part. So what I can say is the group number indicates gives you the number of outer shell electrons. It gives you the number of outer shell electrons for each element. So if I ask you, how many outer shell electrons does sulfur have? E.g., how many outer shell electrons does sulfur S have? The answer is sulfur is in group 1, 2, 3, 4, 5, 6. Sulfur is here in group 6. Therefore, it has 6 outer shell electrons because it is in group 6. That's what it means. So atoms. So when you think about these outer shell electrons are very important, as we will see later. So how are they important? Atoms as substances, the atoms can lose electrons, can accept electrons, can grab electrons from somewhere, or can share their electrons. So what we want, what atoms want stability. So I'll just say atoms want stability. They want to be stable. They don't want to change at all. So what happens? Stability, the atoms are stable only when they have 8 electrons in the outer shell. The atoms, what is this thing doing? Just messing me up. So the atoms are most stable. The atoms are most stable, that is, they are happy when they have 8 electrons in their outer shell. What do we call this? We call it the octet. That is the rule of 8. The octet rule. So the octet rule says that atoms are stable when they have 8 electrons in their outer shell. So why is this important? That's the reason they form molecules and compounds. So atoms form molecules and compounds to fulfill the octet rule. So we make sure you write that down. Atoms form molecules and compounds to fulfill the octet rule. So I'll stop here and then continue in the next video.